Yeah, yeah, I have just turned on the recording. Okay, all right. Now let's continue. So we have XI is the level of rainfall. And what is your model, the population regression model that we can use to test the hypothesis?
The population regression model will be yi equals to beta 0 plus beta
yi
1
beta 0 plus beta 1
times yi square.
yi square
Yeah,
yi square. Okay,
plus beta 2 times yi plus ui.
yi plus ui.
Yeah.
Is this, can you see my screen?
No. I.
Okay, so we have xi here. Hmm.
I speak wrong.
Yeah, is it?
Yes.
Okay, so what is the marginal effect of rainfall on fishery production?
Uh, I think the marginal effect will be the uh, uh, total of beta 1 plus beta 2.
Wait, just wait a minute. Fishery production. Okay, so it will be the what? The sum of
Beta 1,
beta
2
1,
times beta 1
2
plus
times beta
beta 2
1, 2 times beta 1, and
plus beta 2.
plus beta 2, like this.
Uh, yeah,
Is it what you mean?
yes.
All right. So let's see. If there is the marginal effect of rainfall on fishery production, so it means that how can all right. So what will be the sign of what is your expectation about the sign of the regression coefficient?
Uh,
What is your expectation about the sign of the regression coefficient so that it can it can support that hypothesis?
so uh, uh, can I say that beta 1 and beta 2 will be have a negative
Negative. So
side?
if
When beta 1 have negative side,
mm-hmm,
beta 2 will have a positive.
mm-hmm,
Then if the um, chỉ tuyệt đối ạ.
yeah, the absolute value.
The absolute value of two times beta 1 is um, greater than beta 2.
Now,
No,
wait a minute. Wait a minute. All right. So now we talk about the marginal effect of rainfall on fishery production. So the marginal effect of rainfall on fishery production is the first derivative of y, okay, with regard to x, which means that we will take the first derivative of y with regard to x. So what is it? Now
this
take
will be the
2 times beta 1 and we still have one more terms here. What is it?
what is the xi.
Yeah, xi. Yeah, we still have to have xi here. That is the marginal effect of rainfall on fish reproduction. All right. Okay, so now we say that now you can see that as the marginal effect of rainfall on fishery production depends on the value of x. Okay, why x is a variable, which means that the value of x is changing. So the marginal effect of rainfall on fishery production is also a changing value. Okay, so we mean that is not a constant number. All right. So because it is not a constant number, so that we can demonstrate the idea that okay. So at first, the marginal effect of rainfall on fishery is a positive number, but later when the value of x is too high, okay, then the average then the marginal effect of rainfall on fishery production will be a negative number. Okay, and that and that why the fishery production will decrease if the level of rainfall is too high. Okay, all right. So now, what will be the sign of the regression coefficient here? So that it will support the hypothesis that if the level of rainfall increase, then the fishery production will also increase. But if the level of rainfall increase too high, okay, too much, then the production, the fishery production will be decreased. How can we, what will be the sign of the regression coefficient that can help us to support, okay, that can support that hypothesis? Remember that the marginal effect of rainfall here is a line. Yeah, so if you demonstrate it in the coordinate system with in the vertical axis is what is it? It is x, and the horizontal no in the horizontal axis it's x, and the vertical axis is the change in y. Okay, so one will be what will be, yeah, the marginal effect will look like this. Okay, at first it is a positive number. All right, at first it is the positive number. Sorry, at first it's positive number, but when the level of rainfall increase too much, okay, so the marginal effect of rainfall on fishery production will be a negative number like this. So what will be our expectation, what is our expectation about the sign of the regression coefficient?
The sign of beta 1 will be negative.
Yeah, so beta 1 has the negative sign, and what about beta 2?
Beta 2 will be positive.
Yeah, beta 2 has to be positive, right? So this is our expectation about the sign of the regression coefficient. Okay, so that at first when when the level of rainfall increase, okay, so fishery production output will also increase because the marginal effect here is a positive number. Okay, but when the level of rainfall is too high, okay, then as the marginal effect of rainfall on fishery production is a negative number like this, so the overall fishery production output will decrease. Okay, so that is how we expect about the sign of the regression coefficient. All right, what else? Okay, now what type of data should be used to estimate the model? What type of data should be used to estimate the model? So here we want to investigate the effect of rainfall, of the level of rainfall on the total fishery production in northern delta. Okay. So what type of data should be used here to estimate the model?
I think the type of data is time series data. We
Yeah, right.
like
Yeah,
times the level, the data set of high average level of rainfall, and then we
yeah. Okay, so we have the variables here are the level of rainfall and fishery production output of the whole northern delta. Okay, so in order to estimate this model, we need to use time series data, okay, for those variables. All right. Okay, thank you. And what about questions two? What are the other factors that may affect the fishery production beside the level of rainfall?
I think other factors can be the quantity or quality of the uh, food, or
Yeah,
how do you say the
yeah, food quality. Yeah, we can. What is it? Uh, I don't know what is the what that we use for the food for the fishery production. I don't know what do we call it. Do you know what is the word that we
Fish bait,
use? Yeah,
fish bait,
fish what?
fish bait, like 10 câu cá nhỉ?
Người nuôi cá hay cái
10
gì?
câu cá, 10
À,
10
mùi nuôi cá.
10 câu cá, fish bait.
À, thế à? Nhưng mà cô nghĩ là cái thức ăn chăn nuôi ấy, nó có cái từ nào khác cho cái từ đấy không? Okay, so wait a minute. I have to.
speech.
Okay, so help me to find out some more factors that can affect the fishery production besides the level of rainfall, maybe the temperatures, okay, maybe the temperature, the quality of the food provided to the
Contamination level.
yeah, contamination level is good, right? Water contamination. right. Okay. Okay, so there are some factors. Okay, those are some factors that can affect the fishery production. For more factors, you can find out about the fishery production. Researchers about fishery production to see what are the factors that affect the level of fishery production output. All right. So we just named something here, like the temperatures, like the level of contaminations, what else? Food quality, okay, for easily. And what else? The qualities of the yeah, and some more other factors. Okay. All right. So that is for exercise 1. Thank you, Hạnh. Okay. Now for exercise 2, okay, anyone who can help us with exercise 2? Let me give an extra point. Okay. Now, what about exercise 2? Any volunteer? So here we care about the, what is it? Relative effect of electricity price on inflation and the relative effect of gas price on inflation. Okay. Build a model to test the above hypothesis. So which model can give us the relative effect of those variables? Which one? Ngọc Hà. Okay, so Ngọc Hà nè.
I think we used the hypothesis testing.
No, at first you have to specify the model first, okay? Before we do the test, okay, we have to specify the model that can help us to test the hypothesis. Okay, now what will be your model? Here we want to investigate, we want to examine the relative effect. Yeah. Now, which type, which specification of the model can tells us about the relative effect of the variables? Which form tells us about the relative effect? Not the absolute change, but the relative change.
The logarithm.
Yeah, the logarithm model. So here we have inflation expressed in percentage change. We know that we have the unit for inflation is the percentage. So we have, for example, inflation. We have inflation here. Okay, is our dependent variables. Okay. All right. So inflation I, all right, is equal to. So what will be our independent variables here? Independent variables. What are the independent variables of this model?
Uh, that would be electricity price and gas price.
Yeah, electricity price and gas price. But what will be the form of the variables? Is this a linear form or will it be in the logarithm form?
It will be in the logarithm form.
Yeah, okay. So we have here inflation is equal to beta 0 plus beta 1 times the natural logarithms of what is it? Electricity price. Yeah, electricity price. For example, I call it E, for example. Okay, plus beta 2 times the natural logarithm of, okay, so G, for example, gas price. Okay, and plus UI. Okay, so this will be our population regression model that can help us to test the to test the relative effect of electricity price and gas price on the inflation rate. Okay, as inflation rate is expressed in what in a percentage change, so we don't have to take the logarithm for this. Okay, so all right, now build a model to test the above hypothesis. Okay, so here is our questions A. We have the model to test the hypothesis already. Okay, and for questions B, now there is a view believing that even when electricity price and gas price does not change over time, inflation will still increase with time. Okay, build a model to test that view. All right. Okay, so here we should be changed into a T to express time series data. Okay, we change the index from I for observation into T for times. Okay,
There's
into T's for time like this. So now our hypothesis is that beside electricity price and gas price, we still have one more factor that affect the level of inflation, which is the time. Okay, all right. So even when electricity price and gas price do not change, inflation will still increase with time. So we have one more independent variables here, that is the time, right? Time or the change. Now you will be more familiar with the time or the change variables in forecasting, okay, in forecasting in business and economics, okay. But now you haven't studied that yet, but you can see that we can generate a chain variables which has the value of 1 for the first periods and has this value of 2 for the second periods and so on, and it will has the value of n for the nth period. Okay, all right, so here what will be our model to test the effect of time on inflation beside electricity price and gas price. So what will be our model here? We still have inflation as the dependent variable. What will be our independent variables of the model? We will have three
Three,
independent.
price, gas
Yeah.
price, and time.
Yeah, we will still have gas price and electricity price as the dependent variables of the model. Sorry, independent variables of the model. And we have one more independent variable, that is the chain variables. So we have chain variables. We may call it T. Okay, so T has the value of 1. Okay, when b equal to 1, 2, 3, and so on to n, t has the value of 1. Okay, t has the value of 1 of the first observation. For the second, it has the value of 2. Okay, and so on. All right, so if inflation change over time, okay, if inflation change over time, then t will have an effect on inflation, right? But if inflation does not change over time, which means that it does not depend on the time, it does not depend on the change, then the coefficient on t will not be statistically different from 0, which means t has no significant effect on inflation. All right, so here we have the model. What will be our model? We still have the intercept, that is
That will be beta 0.
here beta 0, and then we still have the
Percentage drop.
electricity and gas price in the model as the dependent variables. So we still have beta 1 times the logarithmic of electricity price, okay, plus beta 2 times the logarithmic of what is it, gas price,
Price
okay, and plus
plus the beta 3 of times t.
t, yeah, of course, okay, and plus ut. All right, so that will be the model that help us to test for the effect of change on inflation. So whether inflation increase over time or inflation decrease over time, okay? So the regression coefficient on T will tells us about that, okay? To see whether change has an effect on inflation or not. Okay, so here the hypothesis is that even when electricity price and gas price do not change, inflation will still increase with time. So that will be, if that is the hypothesis, then the regression coefficient on T must be statistically greater than 0, right? Okay. So that is how we develop the model to test the hypothesis that we care about. Okay, all right. So now remember that when you build the model, when you specify the model, you have to base on what is the hypothesis that we want to test. Okay, you have to answer the questions that questions first. What is the hypothesis that you want to test, and which model can help you to test that hypothesis? And remember that the hypothesis, yeah, in order to develop the hypothesis, you have to read previous researches, you have to study the theories, the economic theories. So research hypothesis must depend on those things, all right? And the regression model depends on the research hypothesis, okay? And then, of course, the model will depend on previous researches and economic theories, okay? All right, so that is exercise 2.
Why do we use the logarithm form on this exercise?
Which, can you repeat it? I cannot hear.
I
Yeah,
mean, like,
yeah.
why do we use this? Why do we use the logarithm form on this exercise?
Oh, because we want to test the relative effect. Okay, the relative effect of what of electricity and gas price on inflation. Okay, remember that the relative effect, the relative change, will be expressed in the logarithm form. Okay, the linear form will express the absolute change. Okay. Do you remember that the meaning of the regression coefficient associated with logarithm variables? You can see that when this one increase by 1%, then the other one will change by beta 1%, for example. So those change are relative changes, okay? Not absolute change in the value of the variables, okay? So because here, the questions mention the relative effect, okay, the relative effect of electricity price and gas price on inflation. That's why we want to use the logarithm form of the variables. Okay. All right, any other questions regarding model specification? All right, so one more thing about model specification. So now if I have now if I have yi is the GDP growth rate, we have x is what is the production of renewable energy production. Okay, we have dummy variables, that is d. Okay, that is d equal to 1. It will be developed country, and d equal to 1, 0 represent developing country. All right, so now if I want to test the hypothesis is that, all right, the GDP growth rate of developed country and developing countries are different. Okay, so what will be the model that can help me to test that hypothesis? The GDP growth rate of developed country and developing countries are different. So what will be my model to test for that hypothesis? What would be my model to test that hypothesis? So GDP growth rate of developed country and developing country. Are different statistically different Okay, so what will be the model that can have it to test the hypothesis? What will be the model that can have it to test this hypothesis? Now, class.
Like linear regression model.
Yeah, can you speak louder?
Linear regression model.
Yeah, linear regression model. Can you read the model? Can you just read it loud? What will be our population?
Yi.
Yeah, yi
equal to beta 0
to 0
plus beta 1 di
di.
plus ui.
Okay, so plus ui. All right. Okay, so this model can help us to test the hypothesis that we are stating here. Okay, so now my hypothesis is that GDP, now there is a statistical difference between the effect of renewable energy production, okay, on GDP growth rate for developed country and that of developing country. Okay, there is a statistically difference between the effect of renewable energy production on GDP growth rate of developed country and that of the developing countries. Okay, so what will be the model that can have it to test this hypothesis? Which model can have it to test this hypothesis?
The expected value of yi.
Okay, so we have the expected value of yi.
Di equal to 0.
Is equal to 0. No, yd is equal to 0. Okay, so yd is equal to 0.
Equal to beta 0.
Equal beta 0. You don't have to specify the two case of d. Okay, you just have to put d in the model and the model will tell its story. Okay, the model will itself tell its story. You don't have to write the two case where d is equal to 1, what will be the case when d is equal to 1, and what will be the case when d is equal to 0. Okay, you just have to put d in the model, then the model will tell you if what will happen if we support the hypothesis. All right. So just write the general model. Okay. Now, the general model here, we will have that. Now, our dependent variables, the dependent variable will still be yi. And what will be the independent variables of the model? What will be the independent variables of the model?
DI and SI.
Yeah, all right. So here we may still have xi and di in the model to explain for y. Okay, so for example, like this, we have beta 1 times di plus beta 2 times xi. Okay, but a must have independent variables here is that the products, okay, the interaction term between d and x. Okay, do you remember that? We have beta 3 times di times xi. Okay, this one is a must have independent variables in the model to test for this hypothesis. This one is to test, yeah, this one beta 1 will help us to test the effect of D of the type of countries on Y. Okay, this one will help us to test for the effect of renewable energy production on GDP growth rate. Okay, and this one will help us to test for the different, okay, test for the different of the effect of renewable production of X on Y for developed countries and developing countries. Okay, so if we want to test this hypothesis, you must have to have this interaction term in your model. Okay, so this will be our model. Okay, the model that can help us to test for this hypothesis. Okay, this model can also help us to test for this hypothesis also, because we still have the effect of type of countries on GDP growth rate here. Okay, it can help us to test this hypothesis and also can help us to test for this hypothesis. Okay, all right, so that is model specification. You remember that you have to define, you have to develop the the hypothesis, and based on the hypothesis, you have to develop the model that can help you to test for that hypothesis. All right. Okay, so that is for exercise 1 and 2. We take a lot of time for that. Okay, now very quickly, please use the wedge 3, 4, the 5 wedge 3, 4 here to do exercise 3 to 7. Okay, now quickly, be quick. We do not have much time.
Can I do the exercise?
Yeah, of course. Which one? Exercise 3. Now, just show me your. You can show your. Yeah. Oh, who are you?
My name is Phương.
Okay, so Phương. All right. So I will share the. I will let you share the screen. You do it on your computer. Okay. And tell the class. Okay, Yi-Phương, you can share your screen.
I don't know how to share my screen. Can I just read the result?
Good. All right. So you cannot share your screen. Okay, so wait a minute. Oops. All right. So for exercise 3, okay, what is your regression model?
My population model is weight equal beta 0 plus beta 01.
Which I equal beta 0 plus beta 1.
Education years
Education.
plus residual.
Yeah, no, not the residuals, but this UI. Okay, the residual each just appear in the sample regression model. This one is the UI. All right. So what will be your sample regression model?
My regression model is weight equal beta 0 hat.
Yeah. Now, what is the value of beta 0 hat for this exercise?
Minus 0.75 745.
745.
Yes. 9 plus 0 7 0.7 5 0
Okay, time is u and plus
UI hat and
the residual UI hat. Okay, all right. So this is our sample regression model or the estimated model. Now, just wait a minute. I will do it on Stata. Now, let's try to regress reach on education. Then we have, yeah, correct. That is the answer. Okay, that is the estimation output. All right, you do it right. Now, what about explain the meaning of the estimated slope?
I think estimators show the relationship between the wage and education year of the workers.
Okay, so what is the value of the estimated slope?
Is it 0.75?
0.4.
Yes.
Okay, so what is the meaning of it?
It means that when workers have one more year's education, their wage will increase by 0.5.
Okay, so when workers has one more year of education, their wage will In what?
Will increase by 0.75.
Yeah, 0.4 units on,
wage.
no, not on wage. Their wage will increase by 0.7504 unit on the
Average.
yeah, on average. Yeah, on average. All right. So C, estimate the wage of a worker who has 13 years of education, which is equal to the variable sample mean. Okay. Now 3, with
Teacher,
the, yeah,
I want to ask you because I calculate the variable sample mean and it's not equal to 13, it's equal to 12.
all right. Let me try to check it. So, some education. Yeah. Okay. The mean of education is here is 13.019. 13.019. Not 12.
Okay, maybe I make a mistake.
Right. Okay. So now, if we have education equal to 13, okay, what will be the estimated wage? What will be the estimated wage?
It's about line 0.
Okay, just plug in the number here. Okay, we have education equal 3. And what is the estimated level of wage?
Equal to minus 0.745.
No. What is the final result? What is the final result?
The final result equal to 9.01.
9.01.
Yes.
Yeah. Okay. All right. So what is the questions here? Oops. Now compare the result to the sample mean of wage. What is the sample mean of wage? What is the sample mean of wage?
The sample mean of wage equal to 10.
Is it? How can you calculate that?
I use Excel.
Okay. You use Excel file. Oh, then there must be a mistake there. Now let's sum. Sum, what is it? Wage. Sum wage. And you can see that here, the mean of wage is 9.024. Okay, so we have the mean value of wage is 9.024. Okay, let's compare these two values.
So the estimate wage of worker who has the years of education equal to variable have equal wage, have the wage equal to the sample mean of wage.
It is close. It is approximately close to the mean value. Close to the sample mean of wage here. It's quite close. This one is 9.01 and this one is 9.02. All right. So actually, it should be equal to each other. Do you remember one characteristic of the sample regression model is that it's passed through the sample mean of x and y, which means that we have y, the sample mean of y is equal beta 0 hat plus beta 1 hat times x, the sample mean of x. Okay, so here we have here the sample mean of x here. We should have wedge here equal to the sample mean of y, but because we have some rounding, we have some approximately rounding here, right? We the actual mean, the actual sample mean of education is 3.0 13.3 13.01 what is it 13, yeah, we have 13.018 or 19, okay, but we round it to 13. Okay, all right, and also we have the rounding in the estimated regression coefficient. Okay, this one is not the actual value, just the rounding of it. Okay, so that's why here we have the difference here. Okay, we had a small difference between the estimated wage here and the sample mean of wage. But actually it should be the same. All right. Okay, thank you. Do you have any questions here?
We can't calculate y UI
Hả?
like sao không tính cái UI mũ nhỉ?
Tính uy mũ làm gì?
Tại vì em thấy rằng tức là nó vẫn trong phương trình, thì nếu như mà khi mà cho education bằng 13 vào thì mình lại coi UI mũ bằng 0 thì UI
Tại sao lại coi uy mũ bằng 0?
không, tức là bởi vì khi mà cô cho cái edu bằng 13 vào thì cái wedge sẽ bằng 9,01 nhưng mà không tính UI.
À, đi nhá. Ở đây là ở cái câu này là người ta đang hỏi cái estimated wage thôi. Tức là gì? Mình không hỏi là cái observed wage, được chưa? Mình chỉ hỏi là cái estimated wage. Bây giờ nếu như mà tôi có cái level of education là 13 như thế này thì chẳng hạn, đúng không ạ? Thì cái estimated wage mà cái sample regression model nó suggest nó sẽ là cái gì? Được chưa? Chứ không phải là vậy thì cái actual observed level of wage nó là bao nhiêu? Hiểu không ạ? Vậy cho nên là mình không cần tính cái không cần tính cái residuals ở cái chỗ này. Có hiểu không ạ?
Rồi ạ.
Ok. All right. Now, any other questions here? Okay, so that is for exercise 3. Now, what about exercise 4? Believing that the marginal effect of years of education on wage is decreasing, a student add variable education square into the model. Write the population regression model and the estimated model. Okay, exercise 4. Oops. Now let's think about exercise 4. Now, who can help me with exercise 4? Exercise 4. Now you have to generate a new variables in Stata. Okay, you have to generate a new variables, which is education square. Okay, then you regress the models with education, and we regress wage on education and the square of education. Okay, you can get the model. Now, any volunteer? Any volunteer here? All right. So, in order to generate a new variable, we use the command generate or gen. Đắc Minh. Ok, Đắc Minh có điểm chưa?
Có rồi ạ.
Rồi. Okay. All right, but we do not have much time now. All right, so Minh, help me to do it. You can share your screen. You can share your screen to show how you regress the model.
Em đang dùng này điện thoại ạ, nên là em không có Stata.
Ok, làm sao mà em làm được bài?
Tụi em một chút ạ.
Yeah.
Cô em đọc nhầm đề này, em chưa chắc lắm ạ.
All right. Okay. Nói chung nè. Chung, are you there?
Yes.
Yeah. Just share your screen and show other students how you regress the model.
Can you see my screen?
Yeah, I see your screen now.
So I did the generating before. I did generate edu, variable edu equals to education square. And then I regressed the wage on education and edu. And here is the result.
Okay, I see it. All right. So what will be your population regression model?
My population regression model would be wage equals to beta 0 plus beta 1 education plus beta 2 edu plus UI.
Yes. And what will be your sample regression model or the estimated model?
My sample regression model will be wage equals to beta 1 hat education and plus beta 2 hat edu plus UI hat.
Yeah. Okay. So just replace by the estimated number you get here.
So the beta 1 hat is minus 0.6.
Mm-hmm.
And the beta 2 hat is 0.05.
Mm-hmm. So our estimated model will be that wage is equal to what is it? 7.606, is it? The beta 0 hat?
Beta
yeah,
0,
your
yes,
mouse,
okay. The
your
beta
mouse
0 hat
right
is
over it.
7.5.
Okay, oh, I see it. So wage I is equal to 7.506, okay, plus minus 0.6 times education plus 0.05 times edu and plus UI hat. Yeah, that will be your sample regression model, right?
Yes.
Yes, okay. So the questions here, let's see the questions. What is the marginal effect of years of education on wage?
The marginal effect will be beta 1 plus beta 1 hat plus beta 2 hat education.
You forgot one more thing. That is, okay, the marginal effect of educations on wage here will be beta 1 plus 2 times beta 2
Yeah, sorry.
times educations. So with the estimated results like this, we have the estimated marginal effect of educations on wage is that, okay, so minus 0.6 plus 0.1 times education. Yeah, that is the marginal effect of education on wage. All right, so I have to write it here. Otherwise,
okay. Let me stop sharing the screen.
Yeah, I will write it here so that the student can see it clearly. All right, so for exercise, what is it? Exercise 4, we want to add one more. We want to add the square of education into the model. Okay, so now we will have, all right, the population regression model will be like this. Okay, we have wage equal beta 0 plus beta 1 times edu, okay, plus beta 2 times edu square and plus UI. All right, now the estimated model or the sample regression model will be like this. As the estimated model suggests, we have wage, okay, wage hat equals 7.506 minus 0.6 times edu, okay, and plus 0.05 on education square. All right, for the second questions, we want to ask the marginal effect. The marginal effect of education on wage. All right, so here it will be the first derivative of wage with regard to education, okay, which is beta 1 plus 2 times beta 2 and times AU. All right, and in the estimated result, we have the estimated marginal effect of education on wage is equal to minus 0.6 plus 0.1 times AU. All right. Okay, so for questions 3, where is it? Okay, explain the meaning of the coefficient 0.05 in the above estimation result. That is reflect the decreasing marginal effect of education on wage. Now, Chung, what is the meaning of 0.05 here? Or we can write it like this. Okay, we have plus 2 times 0.05. All right, so what is the meaning of 0? What does 0.05 suggest?
It suggests that the marginal effect is increasing.
Yeah, okay. So it suggests that, all right, so the meaning of, we have beta 2 hat here equals 0.05, okay, suggests that when education increased by 1 unit, all right, the marginal effect, all right, the marginal effect of what of AU on wage will increase by 2 times 0.05 unit. Yeah. Now that it will suggest the change in the marginal effect of education on wage. Okay, and as you see, the change here is a positive change. Okay, it is a positive change. So that it suggests the decreasing marginal return of the decreasing marginal effect of education on wage. That is suggest or implied the decreasing marginal effect of education on wage. Does it? Theo các bạn ạ, ở đây thì với việc cái estimated coefficient here is a positive number like this, đúng không ạ? Thì nó có suggest cái việc là cái marginal effect của education on wage là decreasing hay không ạ?
Không ạ.
Yeah, no. Okay, so because the estimated coefficients on education square is a positive number. Okay, it suggests that the marginal effect of educations on wage is increasing as the year of education increase. Okay, so it does not suggest decreasing marginal effect of education on wage. Okay, so the estimated model, the estimation output does not support the hypothesis here. Okay, the estimated model does not support the hypothesis that we are stating here. The marginal effect of education on wage is decreasing. Okay, so our estimated model does not support that idea. All right. Okay, so it does not reflect the decreasing marginal effect of education on wage. All right, that is for question C. Okay, now what about question? No, what about exercise 5? Let's be quick. Exercise 5. Suppose that wage also depends on years of experience. We add variable experience into the model in exercise 3. So our model here has two independent variables, that is education and experience. Okay, so the population regression model. Now, the exercise 3, exercise 5. So the population regression model here, which they have wage as the independent variables, and we have two independent variables, that is experience and education. What is it? We have experience. Oh no, wait a minute. We have education and experience plus UR. Okay, and what about the estimated model or the sample regression model? Now you have to estimate it in data first. In order to get the estimated model, we have to rack wage on education and experience like this, and then this will be the estimated model. Okay, so we have the constant here is estimated to be minus 4.9. Okay, we have wage, estimated weight equal minus 4.904 plus 0.926 times ASUS plus 0.105 times X bar. Okay, that is our estimated model. For questions 2. Explain the meaning of the estimated coefficients. That is easy one. Okay, so now you can do it at home because it's a very easy questions. So because beta 1 hat, okay, beta 1 hat is equal 0.928. Okay, it means that when education increased by 1 unit and the experience is not changing, okay, the average level of wage will increase by 0.926 units. All right, and the same for beta 2 hat. We have beta 2 hat here equals 0.105, which means that, okay, when experience increased by 1 unit and education is not changing, okay, the average level of wage will increase by 0.105 units. All right, that is the meaning of the estimated coefficient. And remember that when we change the value of one independent variable, when one independent variable is changing, the other one must stay the same. Okay, all right. And question C, in this sample, okay, so only in this sample, we just consider this sample only. If only caring about the level of wage, now I just care about the level of wage. Now, should a worker increase his education time and thus reduce his experience or vice versa? So you know that for one people, the time is limited. When you study more, you will have less time for experience. Okay, so if here in this sample, Now we just care about this sample. A worker, if he want to increase his level of wage, okay, so should he increase his education time and thus reduce his experience, or vice versa? Should he increase educational time or experience time? Should he increase educational time or experience time? Các bạn. No.
I think he should increase his education time.
What is your reason?
Because I see that the coefficient of education variable is bigger than the ones of experience.
Yeah, exactly. Yeah, as you see in the estimated model, in the estimated model for this sample, you can see that the effect of educations on wage is higher than the effect of experience on wage, as the estimated coefficient on wage is larger than the estimated coefficient on experience. So now for a worker who just care about the level of wage, he should increase the educational time and thus reduce the experience. All right. Okay, that is the answer for question C. But remember that here we say that in this sample only. Now, if we want to ask that questions for the whole population of interest, you have to do a test. Remember that. Okay. All right. For exercise 6, so use the provided data to estimate a log linear model with log wage as the dependent variables and education and experience as the regressors. Okay, easy one. So write the population regression model and the estimated model. Now for exercise 6. All right, so we have the natural logarithm of wage as the dependent variables, and we have experience and education as the independent variables. We have ASU here and beta 2 time experience. Okay, and plus UI, there is the population regression model. And what about the sample regression model? Okay, so in order to have the sample regression model, you have to regress the model in Stata. We have to generate a L and wage equal the natural logarithms of wage. Okay, and so we have a new variables here. Now we regress wage on education and experience. All right. Okay, so enter. We have the estimated model here. Can you see that? All right. So this is the estimated model. Now write down the estimated model. We have log wage equal, what is it? 0.954. 594. Okay, plus 0.09. Okay, so plus 0.1 education, and plus what is it? 0.01 time expert, and plus UI hat. Okay, this is the sample regression model. And what is the second questions? The second questions is that explain the meaning of the estimated coefficient. Oh no, yeah. Explain the meaning of the estimated coefficient. Now, for example, we have beta 1 hat equals 0.1. All right, so what does it mean? Beta 1 hat equals 0.1. What does it mean? What does it suggest?
When the student increase their education by 1 year, the corresponding wage will increase by 10%.
Yeah, so when the year of education increased by 1 unit and experience unchanged, okay, and experience is unchanged, so the wage, the average wage of worker, average wage will increase by
10%.
Yeah, by 0.1 times 100%, which is by 10%. All right, so that is the meaning of the estimated coefficient on SU. So similarly, you have the beta 2 hat equals 0.01. It suggests that when experience increased by 1 unit and education does not change, okay, the average level of wage will increase by, okay, 1%, okay, 1% on average. So that is the meaning of the estimated coefficient. Now, can we compare the goodness of fit of the two models in exercise 3 and 5? Oh, sorry, not 3 and 5, but 3. No, let me see what is exercise. Wait a minute. Okay, now what else? What are we talking about here? Exercise 3, wage on education. Right. Okay. So actually, exercise 3 and exercise 6. All right. Okay, so can we compare the goodness of fit of the two model in exercise 3 and exercise 6 using R-square value? Can we do that?
Well, we cannot compare the goodness of fish
using R-square. Why?
Because R-square usually used to compare the how the sample regression life explain the sample data, not the goodness of fish.
Yeah, actually, it shows the goodness of fit of the sample regression model and the sample data. However, you can see that in exercise 3, we have the dependent variable is wage, and exercise 6, the dependent variables is log wage. That's why we cannot compare the two models. Okay, because in exercise 3, we explain for the value of wage, but in exercise 6, we explain for the value of log wage. Okay, and also we do not use R-square to compare the goodness of fit between model with different number of independent variables. So as we say about the weakness of R-square, it is an increasing function of the number of independent variables in the model. So if we use R square here, it is not fair, right? So if we have two models with the same dependent variables and different number of independent variables, then we should compare the goodness of fit between that two models by using the value of adjusted R square. Okay, we do not use R square to compare the goodness of fit between model with the same dependent variables. And of course, in this case, we do not have the same dependent variables in the two models. Okay, that's why we cannot obviously use R square here. Okay, all right, that is exercise 6. Now we have still one more. We have one more exercise here. This one is all about testing in exercise in chapter 4. Okay, so for exercise 7, we regress wage on year of education, experience, and sex. Now, okay, so here in Stata, we have to regress wage on education, experience, and sex. For sex equal to 1, when sex is equal to 1 is a female and sex is equal to 0, it is a male worker. All right. Now, just write the population regression model and the estimated model. That one is quite easy, right? Yeah, you know the dependent variables, you know the independent variables, then you can write down the population regression model and the estimated model based on the estimation output obtained from Stata. Okay, that one is easy. Now, explain the meaning of the estimated coefficient on education and sex. Explain the meaning of the estimated coefficient on education and sex. Here is the estimation output. Now, what is the meaning of the estimated coefficient on education? That is easy one, right? It's the same as the previous questions. It shows the marginal effect of education on wage. So when education increased by 1 unit, okay, and experience sex is not changing, then the average level of wage will increase by 0.94 unit on average. Okay, so what about sex? We have the estimated coefficient on sex is equal to minus 2.3373. Okay, so for exercise 7, we have the estimated coefficient on sex, beta 3 hat, is equal to minus 2.338. Okay, so what does this suggest? What does it suggest?
It is
difference between the effect of uh, uh, of the effects of experience on weight for male and female?
No, actually it's not. We do not have any interaction term here. We just have beta 3 times sex, which is the dummy variable. So the coefficient on the dummy variables here will tell you the difference in weight of the two categories. Okay, the difference in wages of the two categories. If we have an interaction term here, it will tell you about the difference, about the effect, okay, the difference in the effect of the quantitative variables on the dependent variables between the two categories. But here we do not have the interaction term. So the coefficients on sex only tells us about the difference of wage between the two categories, right? You can see that given the level of education and the level of experience, all right? So given the level of education and experience, which mean that education and experience is unchanged, right? Okay, so the average wage of the category, which is equal to 1, that is female, okay, is small, is 2.338 smaller or lesser or less than the average wage of the category of the benchmark category or of the base category, which is male, right? Okay, you can see that from the population regression model. We have the population regression model is that wage equal to beta 1 0 plus beta 1 times education plus beta 2 times expert and plus beta 3 times sex. Oops. And plus UI. Now you can see that the expected value of wage given the level of education and experience, and also for female when sex is equal to 1, okay, that is, what is it? We have beta 0 plus beta 1 times education plus beta 2 times experience, okay, all right, and also the average level of wage for given the level of education, level of experience, and sex is equal to 0 for male, is equal beta 0 plus beta 1 times education plus beta 2 times expert and plus beta 3. Okay, so beta 3 here, yeah, beta 3 here. So no, here is beta 3 here, and this one do not have beta 3. Okay, because 1 here is for female. Okay, so now you can see that beta 3 here is the difference in the average level of wage for male and the average level of wage for female. So when we estimate that beta 3 equal to minus 2.338. It suggests that given the level of education and experience, average level of wage for female is 2.338, less than the average level of male. Okay, all right. So, or we can say that, okay, gender represented by sex here, the dummy variables here, has an effect on the level of wage. Okay, so the coefficient on the dummy variable just tell you whether the qualitative variables represented by the dummy variables has an effect on the dependent variables. If we have an interaction term here, it will tell you about the effect. Okay, it will tell you about whether the dummy variable has an effect on the effect of the quantitative variable on the dependent variables. Okay, that is for dummy variables here. Now, for question C, what is the coefficient of determination of this model and explain its meaning? That is an easy question. What is the coefficient of determination for this model?
R square
Yeah, R square. What is the value of R square here?
is 0.2532.
Yeah, right. That is 0.2532, which means 25.32%. Okay, it suggests that this model can explain for 25.32% of the total variation in the value of wage in this sample. Okay, that is the meaning of the coefficient of determination. Remember that the coefficient of determination is R squared. All right, what about questions? Okay, so does education actually affect wage? If 5% level of significance, so does education significantly affect wage? Here we have to do a test. Okay, you have to do a test, a hypothesis testing. What do we have to do now? So does education actually affect the value of wage? What do we have to do here? Now remember that we have 4 steps. 4 steps in doing a hypothesis testing. What are the steps? And what is the first step? What do we have to do?
Establish the hypothesis.
Yep. Yeah, step 1. Now, for what is the questions here? Questions, let me see. Questions D. Okay, so we have questions D. Now, for D, step 1, we have to state the hypothesis. What is HO and H1? HO, what is it?
Beta 1 is equal to 0.
Yep, beta 1 equal to 0. And what is the alternative hypothesis?
Beta 1 is different from 0.
Yeah, beta 1 is different from 0. Now, if we say that education actually affects wage, it means that the coefficient on education is statistically different from 0. Okay, so what is the second step?
We will find the test statistic.
Yeah, we have the test statistic. What is it?
TS will be equal to beta 1 hat minus beta 1 square.
Yeah, so the observed value of T, the test statistic here will be equal beta hat minus the suspect value and divided by the standard error of beta hat. Okay, so do we have to calculate here? We already have it from the estimation output, right? So what is the observed value of t here?
11.93.
Yeah, so we have the observed value of t here, as we see from the estimation output, that is 11.93. Okay, now what should we use? Which approach should we use here? The test of significant approach or the p-value approach? Which one should we use here for more convenience?
P-value.
Yeah, we should use p-value here because you use the test of significant approach. You will have to find the critical value of t. Now we have the p-value of the observed value of t. What is it? 0.000. Yeah, 0.000, which is very small. Okay, so step 3, we want to compare the p-value with the level of significance. So what is the level of significance do we have to use here?
5%.
Yeah, 5%, 0.05. Okay, so now we can see that p-value of the test statistic is obviously smaller than the level of significance. Okay, is smaller than the level of significance. Then we will reject.
We reject the
Yeah. Okay, and step 4, let's make the conclusions. So, education
is statistically different from
the coefficient on education is statistically different from 0, or we can say that education statistically
significant.
Yeah, significant affect which, all right, at 5% level of significance. Yeah, that is for questions D. All right, we use the test for one individual regression coefficient, and we use the p-value approach because it's quite convenient here, as we have the observed value of t and also the p-value associated with that observed value of t in the estimation output. All right, for questions E, now, is the marginal effect of education on wage larger than the marginal effect of experience on wage? What do we have to do here? Is the marginal effect of education on wage larger than the marginal effect of experience on wage? Which one in the population regression model so the marginal effect of education on wage? Which one in the population regression model so the marginal effects of education on wage?
Beta 1.
Yeah, beta 1. Beta 1 is the marginal effect of education on wage. What is the marginal effect of experience on wage?
Beta 2.
Yeah, beta 2. So now we say that the marginal effect of education on wage is larger than the marginal effect of experience on wage. What does it mean?
It means that we want to test if beta 1 is greater than beta 2.
Yeah, right. It means that beta 1 is greater, is statistically larger or greater than beta 2. Okay, so here you have to conduct a test like this. Okay, for questions E. All right, we have the hypothesis is that, all right, beta 1 as the questions say that, okay, the marginal effect of education is larger than the marginal effect of experience on wage. We have beta 1 is larger than beta 2. Okay, and the null hypothesis is that beta 1 is equal to beta 2. Okay, so now this one is equivalent to HO. We have beta 1 minus beta 2 is equal to 0, and H1 is that beta 1 minus beta 2 is greater than 0. All right, so now what do we have to do here? In the second step, we have to calculate the test statistic. Okay, we have TS is equal to beta 1 hat minus beta 2 hat minus the suspect value, which is 0, divided by the standard error of beta 1 hat. Oops. Minus beta 2 hat. Okay, now we have to calculate the standard error of beta 1 hat minus beta 2 hat. Okay, what is it? Do you remember the formula to calculate it?
It is the square root of variance of beta 1 plus variance of beta 2 minus the two covariance between beta 1 and beta 2.
Yeah, minus 2 times the covariance between beta 1 hat and beta 2 hat. Do not forget the hat here. Okay, all right. So now we have to find the covariance between beta 1 hat and beta 2 hat. We will go to startup and use the command VCE here. Okay, we will get the covariance matrix between the beta hat. Okay, we find the covariance matrix between experience beta hat of experience and the beta hat of education, which is 0.00046. Okay, so we call it maybe 0.0005. Okay, all right, is it? Yeah, it is. Now calculate the standard error of beta 1 hat minus beta 2 hat. What is the final calculation? What is the final result here? What is the final result here?
Can you open the starter?
Yep. You can do it in your computer to get the result. It will be easier to look at the result because when I set the screen, the number is very small.
0.074.
0.074.
Yes.
All right. So we have 0.074 is the standard error. Is it?
Yes.
Okay. So now replace it here. We have beta 1 hat. What is it? Beta 1 hat 0.94 minus 0.113. Okay, and divided by 0.074. Did you take the square root? Did you take the square root here?
Yes, he did take the square root.
Okay, so what is the result here?
11.17.
11.7. All right. Okay. So now let's determine the, you can use p-value approach, or you can use, what is it? The test of significant approach. You can use either one because no one is more convenient here. You still have to look for the critical value or the p-value approach associated with this T1. Okay, so let's determine the critical reason for the test. Okay, so what is T? This one is one-sided. We will need with the larger psi in the alternative hypothesis. So we will need T alpha. What is the level? Okay, do we say what level of significance here?
5%.
Okay, let's use 5% level of significance. So we have T alpha, which is 0.05. What is the degree of freedom? What is the degree of freedom? What?
530.
Okay, 530. And what is the critical value of T? Look it up for me. Được chưa?
1.4.
1.67. All right. So the
64.
64.
Yes.
Okay. So the, what is it? The critical reason. Okay. The critical reason. Critical reason for that we have W equal 1.674 to positive infinity. Okay, so we can see that. All right, step 4, we say that TS belong to the critical region. Then we will reject HO. And then the conclusion. Okay, so at 5% level of significance, okay, the marginal effect of education on wage is larger than the marginal effect of experience on wage. Okay, that is our conclusion for this one. Now for questions F, when education and experience both increase by 1 unit, in which interval will the change in the average wage fall into using 5% level of significance? What do we have to do here? When education and experience both increase by 1 unit. All right, now look at the population regression model. When education and experience both increase by 1 unit, what will be the change in the wage? What will be the change for wage when education and experience both increase by 1 unit? Look at the population regression model. When education and experience both increase by 1 unit, what will be the change in wage? When education and experience both increase by 1 unit, other things constant. Okay. What will be the change in the level of wage? What will be the change in the average level of wage?
Beta 1, the wage will increase by beta 1 plus beta 2.
Yeah, right. The average wage will increase by beta 1 plus beta 2 unit, right? Yeah, beta 1 plus beta 2 units. Okay, so remember what you must notice. You must notice what is the change in the independent variables. Okay, in example, both education and experience increase by 1 unit. In some other exercise, okay, they can ask that, okay, so when education increased by 1 unit and experience increased by 2 units, for example, what will be the change in average weight? You have to answer that questions first. Okay, so the questions is, when education and experience both increase by 1 unit, what will be the range for the change in the average weight? Which means that we have to construct the confidence interval for the change in the average wage. Okay, so which means that we have to conduct, okay, we have to construct the confidence interval, for the change in the average weight, which is beta 1 plus beta 2 in this example, okay, in this exercise. All right, so in order to construct, now we will consider beta 1 plus beta 2 as one independent regression coefficient, and we will construct the confidence interval for that regression coefficient. All right, so in order to construct the confidence interval, we need the estimate, the point estimate. Okay, first the point estimate, which is beta 1 plus beta 2 hat, beta 1 hat plus beta 2 hat. We also need the standard error of the estimate, which is beta 1 hat plus beta 2 hat. And we also need the t, the critical value of t, which is now the level of significance of 0.05 divided by 2, and the degree of freedom is 313. All right, now what is the point estimate for this? Beta 1 hat plus beta 2 hat. What is it? What is beta 1 hat plus beta 2 hat?
Approximately 1.03.
Yeah, 1.03. Now, and the standard error of beta 1 hat plus beta 2 hat? is equal to the square root of variance of beta 1 hat plus the variance of beta 2 hat. And here, because here we have a plus sign, then it will be 2 times the covariance of beta 1 hat and beta 2 hat. All right, and what is the value? Have me to calculate this. What is the value?
Zero point 0.09.
0.09. Okay. And what is the critical value of T?
One point 1.4.
Okay, so as we have the point estimate, we have the standard error of the estimate, and also we have the critical value of T. You can construct the confidence interval for the change in average weight. All right, and then conclusion, make the conclusion. At 5% level of significance, when education and experience both increase by 1 unit, the average weight will change in that interval. Okay, the change of average weight will be within that interval. All right, that is questions F. Now for questions Z, we want to test the overall significance of the model using the level of significance of alpha. Okay, the overall significance of the model. What do we have to do here? Questions Z, G. What do we have to do here? Now, what is the hypothesis? Testing, yeah.
Beta 1 equal to beta 2 equal to beta 3 equal to 0.
Yeah, if the short one, we have
R square equal to 0.
Equal to 0, and R square is greater than 0. Okay, all right. Now, what is the observed value of F?
R square multiplied by n minus k minus 1 over 1 minus R square.
Yes, right. And what is the value of it? Now, you don't have to calculate it anymore. Just look at the estimation output. We already have the observed value of F here. Okay, which is 59.88. And what is the p-value of F? The observed value of F?
Zero point 0.000.
Yeah, 0.00000. Okay, so now we use the level of significance of 1%, which is 0.01. Okay, obviously we see that the p-value of F is less than the level of significance. Then we reject or do not reject.
Reject.
Yeah, we reject the non-hypothesis. All right, so we conclude that at 1% level of significance, okay, then the model is statistically significant. Yeah, that is our conclusion here. Test for testing the overall significance of the model. Okay, so at 1% level significance, and we see that the p-value of the observed value of f is smaller than alpha, then we reject HO, meaning that the model is statistically significant. All right, so that is for questions Z. And finally, for questions F, believing that the age and union also affect wage. Researchers consider adding age and union into the model. Should he do that? If 1% level of significance. Now we want to test the joint significance, okay, the joint effect of age and union on wage to see whether age and union has a joint significance on wage. Okay, so here we will have two models, the unrestricted model and the restricted model. And remember that here we want to add two independent variables into the model. All right, now, okay, so for questions H, all right, what will be our unrestricted model? What will be our unrestricted model?
Wage equal to beta 0 plus beta 1's education plus
Yep.
beta 2 experience.
Yep.
And beta 3
and sex.
And beta 4 unit age and beta 5
union. Okay, plus UI. Now what about the restricted model?
Wage.
We have wage
equal to
beta 0 is the original model, right? Plus is U plus beta 2 times expert plus beta 3 times sex. Okay, and plus UI. This is the restricted model and unrestricted model. All right, so what is the R square of the restricted model? We already have that, which is 0.2532. Okay, 0.2532. Now, what will be the R square of the unrestricted model? You have to regress. All right, you have to regress wage on education, experience, sex, age, and union. All right, then you will get the what is it? R square of the unrestricted model here, which is 0.2649. Okay, 0.2649. Now we will have the all right, we have the hypothesis HO and H1. HO, what is HO?
Beta 4 and beta 5. Beta 4 equal to beta 5.
Yeah, equal to 0, and beta 1 is that beta 4 square plus beta 5 square is greater than 0. Okay, then you have to calculate the the observed value of f. What is 8? Or you can do it here for quickly. We can test. Oops. We can test age and union. All right. Okay, so the F statistic here is 4.22. Okay, the F statistic here is 4.22, and the p-value of the test is, what is it? 0.0151. 0.0151. Okay, so the at 5% level of significance, alpha is equal to 0.05, and obviously we see that p-value is less than the level of significance, then we reject HO. All right, so when we reject HO, should we include H and union in the model? Should he bring H and union, into the model? Yes, the answer is yes, because H and union has the John significant, John effect on which. That's why he can bring H and union into the model. Okay, so that is for questions 8. All right, one more thing I should tell you about this, about the do file. You can see that when we close data, every thing that we done here will disappear. Now, next time when you do the exercise again, you will have to run the regression again. You will have to do everything again. Now, I don't want to do that anymore. I want to copy, I want to save all the command I use here in one file named the do file, so that next time I just have to run the do file and everything will appear in the result windows. Now I have to copy. Okay, I have to copy Ctrl C, Ctrl A. Now I have to copy all the tests here. Oops. Control R, Control R, and then Control A, and then Control C. All right. Now you can see that right beside the data editor, we have new do file editor here. Okay, so you click here. All right, and then Control V. All the command that you use in this session will be right here, and then you just have to save it. Okay, save the do file. For example, I name it. What is it? What is the name of it? Okay, so exercise 7, for example. All right. Okay, so now I will close it. Oh, wait, I have to correct it a little bit. All right. Okay, I will show you later. Now I will close data and everything will disappear. Yeah, don't save. All right. Now I open data again. Where is my data? Okay, I open data again. And I want to get my result, get what I have done previously. So I will open a do file. Okay, so I will do a do file. Where is it? Here, exercise 7, and open it. All right, but you can see that there's nothing here because I forgot one thing for the do file that I told it about the data that I use. All right, so here, because I haven't tell it to do to use which data. All right, so now I will have to, where is it? I will have to firstly, wait a minute. I will have to open data first. I have to add the data first. Where's my note? I will create the work file first. Control R, Control C, and Control V. Okay, I will save the data. What is it? Okay, so data for exercise 7. I name it exercise 7. Okay, so I have the data set for exercise 7 already. All right. Now I will have to tell do5 to use. Okay, to use which one? See, desktop. Now the location. Where's the location for this one? Now properties. We will have the detail of it, the location. C user HP desktop. Okay, use C. Oops. C user HP desktop. Is it? User HP desktop, right? And name, and the name of it, exercise 7. Okay, now I will copy all. We will ask data to execute. Where is it? Here. To execute this. All right, now let's see what do we have here. Oh, can you see it? All right, so I will do it again. Now, oh, cancel. That's my do file. I will close it. Close it again. All right, so let's see the do file here. Do it has the use now? All right, we will write the command use and paste the link. Oh, not here. See, oh, user HP. That's my location. Desktop and exercise 7. Now remember to save it first. Okay, save. All right, I save it. Okay, you see. Now this is the result. The result window, there's nothing. Now I will run the do file. I will run the do file. Okay, I will select all and run the do file. Okay, so everything will appear here. Okay, from the beginning to the end. All right, and you can see the end of do file is here. So do file is simply a set of command. Okay, a set of command that you can use to achieve to save what you have done in the previous session. All right, okay, so that's how you generate the do file for your group work. Okay, you will have to generate your do file for your group work so that when I run the command again, I will see what you have done for your group work. All right, okay, so that is all for today. Do you have any questions regarding the exercise? This is the final lecture, okay, for the course, and you will take the final test on October the 22nd. Yeah. Do you have any questions?
How would we submit the do file?
Hmm?
How would we submit the do file?
Yeah, you will have to submit your do file with your data and also your report. Okay, so what you have to submit include your report, maybe in PDF or in what format. Along with that will be your data for your the group work and also for with the do file that you have created. Okay, there are 3 things that you need to submit for your group work.
Okay.
Yep. Any other questions?
Yes, I want to ask that if one variable in multiple model is not statistically significant, when is to be valuable in simple model?
Okay, so when we in practice, when we regress the dependent variables on the independent variables, there may be some independent variables that is not statistically significant. Okay, but as theories or previous researchers suggest that it has a significant effect on the dependent variables, then you will not omit that independent variables from the model. Okay, the reason why it is not significant in your sample maybe is because of your samples, not because of the relationship between between the variables. All right.
Yes, I understand. Thank
Yep.
you.
Okay. It is normal to have insignificant independent variables in the model. Okay, it is normal to have some a little or some insignificant independent variables in the model. But if all the independent variables are insignificant, that is a problem. Okay, that will be a problem. Okay, any other questions? All right, if not, goodbye. All right, and hope that you will study well for the final exam. If you have any questions, you can ask me. And remember the deadline for the group work submission. All right. Okay, so bye-bye.
Goodbye, teacher.
Bye. Yeah.
Goodbye, teacher.
Bye, teacher.